So what happens if I'm trying to find an exponent, like in this equation to find x? I've got two options. First option is to try to make these two bases the same by substituting in an equivalent value. So for example, I recognize that 9 is the same thing as 3 squared. There's my 9. And I know that 27 is 3 cubed. So there's my new 27. And now that these bases are the same, I can ignore the 3's as bases and just work with the exponents. And here we're using our exponent law. Exponent to an exponent, we multiply. So 2 times 3x plus 1 is 6x plus 2. And 3 times x plus 2 is 3x plus 6. Subtract the 3x, subtract the 2, and our x value is 4/3. Here's a compound interest formula, and let's say we deposit $1,000 into the bank and want to find out how much time, how many years it takes to double our money if we get an interest rate of 3% and interest is compounded monthly, 12 times a year. So we're trying to find that t in our exponent. So let's simplify this first a little bit. Let's get rid of this 1,000 by dividing by it. So there's my 2 on this side that shows I'm doubling. And now let me simplify this parentheses to 1.0025 then to the 12t power. Now in this case, I'm not going to be able to make those bases the same. So now comes my second option, which is to use logs. So I will rewrite this in log form. So this will turn into log with a base of 1.0025 of my answer is equal to my exponent. So to evaluate that log on my calculator, I will do log of 2 divided by log of 1.0025, which is 277.6. And when I divide by 12, I get about 23 years to double my money. Logs have their own set of laws to go along with them to help you either simplify or expand log expressions. So the first law is the power law that says if I've got a coefficient in front of my log, I can move that coefficient up to be a power. So 3 log x is the same thing as log x cubed. The quotient law says when I am subtracting two separate logs, I can combine them together into one single log with the same base of the two answers, the x and the 8, being divided. And lastly, the product law says that when I have two separate logs being added, I can combine them into one single log with the same base of my answers, the x and the y, being multiplied. One other thing to remember here, this log base e that I'm written is the same thing as doing ln of x plus ln of y, which would equal ln of x, y. We'll end up using some of the laws of logs to solve this equation for x. So first thing that I would do is our power law. Let's move the 2 up to be an exponent or a power. Now I see two separate logs being subtracted, so this can be rewritten as log of x squared over 12, which is then equal to 3. So now we're at the point where to one single log, now we need to get rid of that log by exponentiating, because logging and exponentiating are opposites of one another. But in order to turn this into base exponent equals answer form, we need to know what the base is of this log. There's nothing there. So that means that this base is a 10. And now when I go base of 10, exponent of 3, that should equal my answer, x squared over 12. And now I know 10 to the third power is 1,000. And then multiplying by 12 would give me 12,000. And then to get rid of the 2, I will square root both sides. And that will tell me my x value is right about 109.5 to the nearest tenth.